Now, I've been talking repeatedly about that the computer only holds binary and that's how we code it that converts it to other things. If we're going to be looking at text images or text, we're going to look at using ASCII, which is some binary representation in 8 bits of all the different characters, symbols, and a few other things like val, character return, and non-printable characters as well. So you have 8 bits and you have all those 256 values that you can assign to characters, and so a capital A has a different character or digital value associated with it from a small a. Now, there are other systems that convert text to other formats as well. One you might be aware of is Morse code. Now, Morse code does not have, it uses dots and dashes, which we could think of as ones and zeros, but it is not every character is the same length. In ASCII, every character has 8 bits. In Morse code, they're a variable width. So an E is a dot, and a Z is a dash, dash, dot, dot. The values were selected based on the frequency. So in English, so if you have letters such as E, which are used a lot in English, by having a smaller number of values used to make that E, it's quicker to send over the network. Longer, but to do that we have to have longer values for characters that are not used very often, such as Z, or Q, which is dash, dash, dot, dash. This only works in English. It only works for standard English. If you were sending a mathematical textbook using Morse code, how many Z's, Q's, R's, Y's are going to be in that mathematical textbook? A lot. So it's actually going to be bigger and less efficient. The idea was that you make it more efficient so you can send more information over a given bandwidth on the network. We do the same thing today, and one of the ways we can do that is called compression. And we do that by assigning different values for the characters. And one of the fundamental ways of doing it is called a Huffman code. And in a Huffman code, what we do is we use ones and zeros, we use binary, but we encode the characters A through Z and punctuation, and we encode them based on the frequency. So we take the block of text, we figure out the frequency of each letter, and then we encode that. So the most common values get the shortest codes, and the least